pH, pOH, all these things. And I know that's been a long time ago, but hey, this is stuff you need. And I've seen that people have asked, people who do chemistry phase 4, they have actually asked some questions related to pH and pKa and things like that. So, you know the stuff. And it's not just sort of silos. This is what we have done in this module. We don't need to apply that to anything else that we are doing. It should all come nicely together. So first of all, we started with, when we discussed this topic, we started with acids and bases. We gave a definition which is the most common one by Brønsted, where we have a compound XH plus water, and that dissociates into H3O plus X minus. And here this one is the acid, obviously, because it's a proton donor. We also can say X minus plus HO gives XH plus OH minus. And in this case, X minus is the base of the whole thing. And we said that in this case, XH and X minus are the conjugate acid-base pair. So according to Brønsted, an acid is a proton donor, a base is a proton acceptor. And then there are variations to that. For example, Lewis' definition of acid and base, which you probably have done in your chemistry module. The difference between an acid and a base within a conjugate acid-base pair is just simply the presence of a proton. So if you have, let's say, H2O, H3O plus, and OH minus, you would have these two as a conjugate acid-base pair. You would have these two as a conjugate base pair. Is this a conjugate base pair, H3O and OH minus? No, absolutely right. It's not, because the difference is 2 protons. Yeah? Fantastic. Now, we said we can measure the proton concentration simply by using a pH electrode, and you've done the experiment with that. And we said the pH of a substance is defined as the negative log of the proton concentration. Yeah? And that's quite important that you remember that. We also said that pOH equals the negative log of the OH minus concentration. And we further stated that pH plus pOH equals, what was it? The magic number? 14, thank you. Yes. So it's very easy to convert pH into POH and the other way around. Yeah? And obviously these are equations that I would expect you to know. If you've been given a pH and you want to convert that into proton concentration, again, it's pretty easy. What you need to do is H plus equals, you take both sides to the power of 10, so that would be 10 to the power of minus pH. It's just simply a mathematical operation for that. We said we occasionally have some problems when it comes to the proton concentration, because sometimes it's not really obvious what our proton concentration is. If we got, for example, an acid, and we said, oops, and we said if we've got a very strong acid, like HCl, we can assume that the acid almost completely dissociates. So we've got H plus plus Cl minus, and it's basically completely gone. And our proton concentration in this case is the same as the acid concentration that we started with. Yeah? So for a very strong acid, we can say pH equals minus log of the acid concentration. Yeah, does that make sense? But that has to be a really strong acid in this case. If we don't have a strong acid, so a weaker acid, well, let's say just weak acid. Weak acid, bless you. So for example, acetic acid, often abbreviated as HAC. This acetic acid will obviously, again, like the strong acid, it will dissociate into H plus plus AC minus. And again, you see here we have a conjugate acid-base pair. But the dissociation is not complete like we had with the strong acid. It's just partial. So that's why the acetic acid is much weaker than, let's say, hydrochloric acid. And therefore we said, well, we don't actually, there is a difference between this one here, between the protons that are produced and our starting concentration of the acetic acid. So in this case, we learned a different equation. We said in order for a weak acid, the pH equals 1/2 of pKa minus log of the weak acid, the starting concentration. And again, that is an equation that you would expect you to know. here the pKa, we said pKa is a measure of how much the acid actually dissociates. So pKa indicates the strength of the acid. With low pKa, is a low pKa a strong or weak acid? Low pKa, you say strong? What? Strong or weak? Strong acid. Low pKa, strong acid. So the lower the pKa, the stronger the acid. And as a rule of thumb, I do not expect you to know pKa's by heart. So if no pKa is given, you can assume, safely assume, that your acid is strong. So no pKa given, acid is strong. It's very strong. Which means you don't really have to worry too much about equations. You just simply use this equation here. If a pKa is given, you need to assume that the acid is not strong, and therefore you would need to use this equation. And what I would expect you to be able to is also that you can sort of play a little bit with this equation. Yeah. So for example, this is actually a technical application. If you have, for example, an unknown acid and you want to find out what the pKa is of this acid, how much this acid actually dissociates, what you can do is you can rearrange this equation. So let's quickly do that. We bring that 2 to that side. So we have pKa minus log of the concentration of the weak acid equals 2 times pH. So the 2 goes over to the pH. We bring that to the other side. And we get pKa equals 2 times pH minus the log of the acid concentration. And the acid concentration, you just simply weigh in a certain amount. If you know the molecular weight of this thing, you know what the concentration of your solution is. You just put in the pH meter, you measure the pH, you know the concentration of the acid, and you get the pKa. Could be a question actually in an exam. How do you find out the pKa of an unknown acid? I like that. You are absolutely right, it's a plus. Thank you. At least One is awake. I'm asleep. Thank you. So 2 pH plus log weak acid. Okay, does that make sense? Yeah? Oh, for... We also said there is a relationship between pKa and pKb. pKa plus pKb, if we add them together, we get what? What's the magic number? 14. We get 14 again. So that allows you very easily to convert a pKa if you only have the pKb and the other way around. We set for pure water the concentration of protons times the concentration of the OH minus ions is 1 times 10 to the minus, what is it? 14. Exactly. What would be the unit for that? Sorry? Molar squared. You are absolutely right. Molar squared. Exactly. Because that has the units of molar, that has the units of molar. And this is, again, here our 14 turns up again. What's the pH of pure water? Sorry? 10. 7. Okay, pH of pure water is 7. What's the pOH of pure water? Is 7 as well. So pH and pOH of pure water is both 7. It's very difficult, not impossible, but it's rather inconvenient to measure a pOH. So therefore people usually measure pH. And then if you want to have the OH minus concentration, you can very easily, with this relationship pH plus pOH equals 14, you can convert one into the other one. Right. So what else did we do? Yes, we said actually what happens if we have a mixture of acid and conjugate base. And it has to be this combination. Acid and conjugate base, or if you like, base and conjugate acid is the same thing. But if you've got a mixture, then we need to apply the equations for a buffer, which is the Henderson-Hasselbalch equation. And this can come in two different flavors. You can write it as pH equals pKa minus log of the acid concentration divided by the base concentration. And I probably put that in brackets. So that's one form, and that allows us to calculate the pH of a given solution just simply by knowing the ratio of acid to base. And of course, we need to know the pKa. You can turn this equation around, and that's the second form. pH equals pKa plus log of the base concentration divided by the concentration of the acid. Again, I put that into brackets. It is just simply a matter of taste which way round you want to have it. When I learned that stuff, I always went for the minus acid over base. If you want to prefer this one here as a mnemonic, Klapper is a positive bastard, then be my guest. If you want to write that down in an exam, be my guest as well, because exams are anonymous and I can't even give you a bollocking or a prize if you write that down. So, yeah, feel free. Personally, I'm not at all offended. We also said that when we're looking at a buffer, we very often talk about the capacity of a buffer. Capacity of a buffer. And the capacity of the buffer is basically the concentration of the acid plus the base together. Just to give you an example, if we have 150 millimolar capacity of a buffer, in 1 liter, that means we have 150 millimole total. Oops, sorry, it's not millimolar. In this case, I want millimolar, millimoles, and that could be, let's say, 75 millimole acid and 75 millimole base. If we have a situation like that, what would be the pH of a buffer where we have that? What's the pH of this buffer? It is pKa, exactly. So in this case, pH equals pKa. Because the concentration of the acid and the buffer is the same, we get base over acid equals 1. Yep. Log of 1 is 0. So we have pH equals pKa. It's actually quite a neat way, again, to find a pKa of a buffer. All you need to do is take the same mole amounts of acid and base, mix them together, and measure the pH. Is the pH of a buffer dependent on the volume? Is the pH of a buffer dependent on the volume? What do you think? Well, let's look at it. Let's take this example here. So we say pH equals pKa minus log of the acid. So we have got 75 millimole per 105 milliliter. I just make something up here. Divided by 75 millimole per 105 milliliter again. What do you see with the milliliters? What happens to them? They cancel each other out. So the volume cancels each other out. If the two volumes are different, yes, it would matter. But how are you going to achieve that? Bearing in mind that your buffer is one solution. Yeah? And in this one solution, you've got the acid and the base together. So realistically, you can't have different volumes. So the volume would always cancel out. What you will what could happen, however, is if you add, for example, protons to a buffer. In this case, the volume changes for both acid and base, but we said the volume doesn't matter. But if you add protons to a buffer, your acid concentration will go up. What happens to your base concentration? It goes down. Base goes down. And the best way of dealing with a situation like that is always to check out how many millimole or mole or whatever you have. So if I add, for example, here to this one here, if I add 10 millimole protons, I would get 85 millimole of the acid and 65 millimole of the base. And obviously in this case then pH is no longer pKa. In this case, the pH would go down, which makes sense because I add protons. But it would not go down as dramatically as if I add these protons just simply to water. And we did an example in one of the workshops, and just as a little tip, very smart students will go back to this example where we said buffer, we add protons. How does it change the pH? Protons we add to water. How does it change the pH? I would go back to this video that we did in this workshop, which is on Moodle and on YouTube. Just as a sort of, a suggestion. Of course you don't have to, but why make life difficult? Does that all make sense to you? You've done that last term. You should really feel very confident with that stuff. Any questions? No? In this case, I suggest that we are going for lunch. I call it a day today. But please do me a favor. Do me a big favor. I heard that the module evaluation for Bi308 are open. Is that right? Yep. Please, please, please tell me what you think about the module, what you liked, what you didn't like. I don't take it personally. Well, yes, I do take it personally. Yeah. But since it's anonymous, you can basically say whatever you want. Klapper is a horrible person or something like that. I would have to accept that. And I have written already the exam paper, so I can't change it. So please be honest. Tell me what you think about it. What you think, for example, about the live streams and things like that. Because every feedback is very important to me and very valuable, because I want to improve. Thank you very much, and I shall see you next week for our last session. Take care and have a great Easter. Okay? Bye-bye.